All right. Well, we got the recording going already. So we go ahead and kick things off here.
Yeah, let's do
Welcome
that.
everybody. Yeah, welcome everybody to this webinar on designing modern Wi-Fi networks with the special focus around roaming capacity and redundancy. And I've got a very special guest on this webinar. Peter, you want to introduce yourself?
Yeah. Hi, everyone. I'm Peter Mackenzie. I work in the UK as a Wi-Fi engineer, trainer, expert, consultant, pretty much, anything really in the Wi-Fi industry. Running a company called MQ Training, where we do all the Hamina training as their official training partner. So happy
That's
to be here today.
Yeah, that's right. Yeah, you want to tell us a little bit about the training options that are now available? I get that question pretty much multiple times a week, I would say, and it's becoming more and more frequent. But yeah, we now actually updated our website just recently. I don't know if you've got some slides to share, but I'll start off by just kind
Yeah,
of showing if you go to hamina.com/training, you can see those different options posted there as well.
Yeah, absolutely. I will. I'll share my screen and just talk through the three different options we've got. Let me quickly do that. So I'll just make this move a few stuff out of the way on my desktop. I seem to have all the Zoom window open. But yeah, so we've got uh, uh, three basically classes that we've developed, or one of them we're still developing here. The certified, Hamina certified network architect is our 4-day class, which we launched in February. We taught the first ever class at WLPC in Phoenix. So that was certified the first 25 people in Phoenix. It seemed to be well received. And that class very much is a class that's designed to take someone um, potentially who has very little Wi-Fi knowledge, well, medium to little, I would say, and even hasn't touched a Hamner tool, and take them within 4 days through the how to design Wi-Fi and how to do it using the Hamner tools. And really to the object, I guess, of that class when I was designing it was that students would leave with a repeatable this methodology for designing Wi-Fi and designing good Wi-Fi that works and works first time. So that's the goal of the class. Um, and but it's also written in a way where I think even if you've been using Wi-Fi for a long time, even if you've been using Hammer, there's still stuff in the class I think for people to learn from. So in Phoenix, we had a bunch of CWNEs take the class, as well as some people who'd had quite extensive experience in Hammer, and I think they all still learned something in the class. So it's
Yeah,
really
and
a class suitable for everyone.
I was able to attend that class at WLPC. I thought it was fantastic. I was very impressed. I know I've sat through several of your trainings in the past. The other one that comes to mind that I was in with you was your CWAP class, the Certified
Mm.
Wireless Analysis Professional one, which was super helpful for preparing for that exam. Yeah, so I've always really appreciated Peter's way of teaching these very technical topics and being able to break them down that are easy to digest. So if you're somebody that's new to Wi-Fi or are very experienced in it but want to know how to design for like the topic we're going to be covering today around modern Wi-Fi networks, and need some help on how to either get started with that or just how to get up to speed with some of the latest changes in the industry and how to account for all the stuff like Wi-Fi 6 and Wi-Fi 6E and all that. I'm seeing several names in chat and in the attendees list that I know are in the class as well with me. So yeah, any insights that you have for other folks, feel free to throw it in chat. You know, if you guys have any feedback and stuff on the class, if you found it to be valuable, definitely love to hear that.
Yeah,
But yeah,
definitely. Yeah, do let us know your feedback. And then we've got two sort of 1 day more product training classes, I would say. One on the network planner tool, which is basically how to use a network planner tool, and then one on the on-site for surveys. The planner specialist class just basically takes you through using that tool. It's really designed for people who already understand wireless design. So there's not a lot of teaching about how to design Wi-Fi. It's more the assumption is you know that, but you want to transfer those skills to the Hamina tool. So that's really the planner specialist, and we do that in a day. It's very, I would say it's 80% labs is that class. And then the survey specialist class is actually not quite out yet. We're still developing that class, but it's very close. If people have a particular interest in it, let me know. And that's going to be all about doing surveys and using the Nomad and the on-site software in 1 day. So they're the three classes. The next class is actually the network architect class. I'm actually teaching one next week, but that class is sold out now. So the next online class that you can book on the next network architect class is going to be on the 10th of June. And we actually did, for the class next week, we did a sort of crazy discount offer in the Hamina newsletter, and people seemed to love it when we gave people 40% discount. So I thought, let's do another crazy offer on this webinar to the people who have come and listened to the webinar. So I've gone for that. So we've got another let's give away loads of discount offer for the June class, which is the 10th to the 13th of June. There's a 40% discount code on the screen. It's Walworth's Web 2024. There's even a QR code to the registration page to make it easy for you folk. So if you want to book on that class and you're on this webinar, you can get a big 40% discount as a thank you for signing up to this webinar.
That's awesome. I did see a question in chat around that's the US course. Is there any options available for folks in the EU?
There is an EU class also scheduled. What I'll do is I'm happy to extend its discount to the EU class as well. It won't work this minute, but if you wait till after the webinar, I will add the EU class to this discount.
Awesome. Thanks,
How about
Peter.
that?
And there was a question about in person. So these are virtual instructor-led classes, correct?
Yes, at the moment, we are. We're looking at putting on an in-person class in the UK very soon as well. I'm just trying to finalize a venue for that at the moment.
Awesome.
But we're very much going to scale these classes to the demand. So if anyone listening goes, hey, there's a bunch of us who'd like an in-person class in a location, let me know and we can schedule a class. We are looking at potentially scheduling a class at the Titan Wrench in Arkansas in the US as well later on in the year.
That's awesome.
So again, if you're interested, if that was a location that you're interested with, let me know and I can send you some details.
As someone that has been out there before, yeah, the Titan Ranch is a very cool venue to do a training at. So those of you that don't know, that's a Titan Titan II missile silo, right? That's
It is, yeah.
renovated to yeah, a training space.
So yes, if you want to learn about Wi-Fi underground, that's quite a unique opportunity.
Awesome. Very good. Very cool. The last thing I'll say on the HCNA stuff, or I guess question for you, Peter, is my thought after taking that class is for anybody that's even pursuing a CWNA certification. That's a really good class to kind of help prepare you for that certification, for that exam, I should say, right? I feel like a lot of that content that's covered in the HCNA class covers a lot of the stuff that's in the CWNA, CWNA exam. Would you agree
Yeah.
or?
Yeah, no, absolutely. I would agree. There's a lot of content in that class that covers sort of CWNA basics as well. The idea really is we teach a lot of all the Wi-Fi concepts you need to know to design a wireless network successfully. And that just happens to have a big overlap with CWNA.
Cool. Excellent.
Nice.
All right. Oh, and we've got another guest that has appeared. UC, you're on the line, and now you're muted.
Hey guys, greetings from Estonia. I thought I was joining as a participant, but it made me somehow host.
You took over.
Yeah, you just
No,
took
I
over.
didn't. Hey Peter, how are you?
Yeah, very good.
All good.
I'll just mute myself and I'll be silent here. I promise, at least for the next 2 minutes.
Sounds good. Well, we'll cover as
Okay.
much as we can in 2 minutes then.
I'll set the
Awesome.
stop clock.
All right. Well, let's dive into the topic of this webinar, which is around the modern Wi-Fi network. So I'm going to take over the screen share here for a minute, Peter,
Yeah,
and what I'm going to
absolutely.
show is what I would say is a common kind of situation, right? So let's start with kind of what not to do, if you will, right? Or why is this, kind of maybe a bad design? So this is like a very common situation that we run into these days, right? Of inheriting maybe an existing network or something that's been out there now, maybe was designed, let's say, around 5 years ago. It's designed for more for the 2.4 side of things, not so much for 5 and 6 gigahertz, and we
Yeah,
want to
you've
bring
painted
this
it
thing.
green, haven't you?
Yes, exactly. So we've got
It's
this nice
very
green
green.
heat map. It
Yeah,
looks
yeah.
good, right, from a surface view here when we're looking at both 2.4 and 5 gigahertz. Obviously, when we start to focus in on things like 5 gigahertz, now it starts to not look as pretty. But what does that mean from a user experience standpoint, right? So let's just look at this real quickly and say, okay, if I go to our client view, and let's just bring a client in. Here's the hospital lobby here, and somebody's going to take their phone out and they connect to the Wi-Fi. And so far, things look pretty good. We can see a little bit of concern here where our radio capacity is running at 90%
Yeah.
based on the users that I put into this network. But what happens is this user starts to move around in this environment, right? So here we can see that the user experience is starting to degrade here. The data rates are dropping, the signal is dropping, and as they start to move throughout the environment, you'll notice here now they're on 2.4. They're still able to stay connected, but as they start to move around this environment, we're going to see what ends up happening. So as they're in the hallways, things look okay, things like that, but as they start to move into other areas throughout the building, you're going to see that user experience kind of fluctuating, right? It's not a very consistent user experience as they're going through. Here now they just roamed over to this radio, and now we've got a red client here. And what's happening here is this radio is running at 100%. So they've roamed over to 5 gigahertz, but that 5 gigahertz radio is running at 100% based on the number of clients that are all associated to that AP. And as we continue to just kind of move that client through there, you kind of see what that user experience ends up looking like. So not a super great experience here. Now we've roamed over to another AP that's running at 110%, and we're on
And
2.4.
on two
So
four, and
yeah,
2.4 is often, over saturated, isn't it, by just having 3 channels? And how
yes,
often do we get that, intermittent wireless problems where someone's saying, "Oh, actually, sometimes I connect okay, sometimes I have problems," and it turns out it's because they've roamed onto 2.4 gigahertz, and that they're suddenly sharing 3 channels with, the rest of the world.
yep. So Peter, can you help me fix this? Can you make this a nice, reliable, robust RCR design, right? We're all about the RCR in this webinar.
We're all about roaming. We're all about capacity and redundancy. And I think there's a couple of things to say is when you have a network like that, and it's not great, is it? It's a poor experience, but it looked okay. And some people go, oh, one thing that's you might go, well, oh, maybe having a bad roaming experience. So why don't we just turn on that checkbox 802.11f, that's roaming. That'll fix everything, won't it? Because then we've enabled roaming on the wireless LAN. I see some people do that, and then they still have a poor experience because the network's never been designed for roaming in the first place. So when we come to designing a network, we want to actually start to design it for roaming. So maybe I'll just chat through a couple of things here. Let me share my screen. Just go back to my PowerPoint slides, and I'm going to talk very quickly just about some thresholds and signal areas, which is something we chat about actually on the training class. It's one of the slides from it, but we've often in Wi-Fi, we're very used to designing for a particular primary signal strength. You'll see my primary signal strength written on this slide, and that might be, say, -65. That's how we paint our network green. And we often think about that as saying, well, this green area is where we get the best performance. It's where we want our users connecting. But there's other areas which are also important. Because beyond -65, once, as we saw when you were roaming your little men around, you left that -65 and you didn't leave the AP, you kept connected to that AP. So we enter a area after -65 or 67 or whatever you set your primary signal strength as, into an area which I like to call the roaming capacity and redundancy, the RCR area. Okay, it's an area where a client is going to hopefully make a roaming decision and roam. So this is an area that becomes really important to us that we need. And the way we tended to often talk about designing that in has been to design secondary coverage in. So I'll just quickly go to a Hamina, and we'll just think about how we might design that in, and then we'll talk about whether that's good enough or not. So I've got a little building here. It's a hotel. It's got everything modeled in it, as you can see. So it's got all our attenuations, walls, and everything modeled in it. And we're just going to throw some APs on here to do a very quick wireless design. So I can pop some APs on. And if I was designing for primary coverage, I just literally keep clicking access points and try and make this map green. Whereas secondary coverage is looking at the second strongest AP. And that tends to be what we talk about when we want to design for either redundancy or roaming. And very often that's going to involve having a few more access points on this map. So let's just pop a few more APs on and try and just get this map covered with some secondary coverage, and then we'll talk about it. So I'm just going to very quickly pop some APs into these areas. Okay. Let's stick one in the office there as well. So I'm maybe not worried about getting the best full coverage on secondary coverage, but if we look at this now, if I looked at my primary coverage, as I just placed another AP by mistake. But if we look at this and I highlight it on 98% coverage, primary coverage, and I'm missing a bit in the changing rooms, I'm not too worried about that. So we might go, oh, that's great, I've got great coverage here. When we look at secondary, we sit there and we'll say, well, I'm 77%. So is that good enough? And is the areas where I maybe have, not got enough? And I've not really drawn any out of scope zones. So I could sit there and say these elevators and the void there is out of scope, and there might be a few other places. And I might want to place another AP over here. But if I now look here, 80%, is that good enough for my roaming, my capacity, my redundancy, all of that sort of stuff? Excuse me one second.
Yeah,
So
usually what I'm looking at for the secondary is where are the users going to roam, right? Where are
yes,
the users going to be mobile in those areas where they're going to have those roaming events happen.
exactly. So where we've not got secondary coverage towards the edges, you might go, well, actually, does that matter? Because if I'm in a user in this room, I'm not going to roam out of the building. So secondary coverage is all about, do I have a second AP I could roam to? So I'm not bothered about the corners, the edges. You could argue it. I'm struggling a bit in some of the bathrooms, but again, if I'm in the bathroom, I'm only going to roam into the coverage, not away from it. So we could look at this and say, well, actually, it's the edges, the corners, and actually, from a roaming point of view, that's fairly good. Okay, that's one thing we could talk about and discuss and say, actually, our roaming's pretty good in that scenario. And you know that might be okay. But if we wanted redundancy, AP redundancy, so let's say this was not a hotel, it was a medical facility where we've got medical devices, and if one AP goes down, it's imperative that our devices can stay connected, then actually having a dead spot in a room might be a problem. So one of the important things when we're talking about secondary coverage is, why do we need it? Is it just for roaming, or is it for redundancy as well? And if it's redundancy as well, that's when we might want to get full coverage, and we might not be happy. So a lot of it comes back to, do we understand our requirements and why we have them, for what percentage we'd want to cover. So I think that's very much what I've just discussed, is very much how we've done Wi-Fi design up to this point. But my question is that good enough for modern day wireless designs? I'll just go very quickly back to this diagram because I want to talk about this area in a bit more detail. You see, secondary coverage ensures that I can hear a second AP, but it doesn't necessarily always make sure I've got enough secondary coverage. You see, this area becomes very important. It's not only that, how can I put it? It's not only that it's important, it's that I actually need it, because I need some yellow area to give my clients a chance to roam. Okay. If I don't have any, they're not going to roam. So what I end up talking about is a threshold, which I've got here called a design roaming threshold. And this is a threshold at which my clients will roam, or which I expect they'll have roamed by. So iPhones roam at minus 72 dBm. So I could set that at 72 dBm. Or I might go a little bit lower, saying that I expect them to have roamed by this threshold. Then we move into the sort of yellow area, which I say is per performance. We don't want our clients connecting in that area because they're going to get a low MCX rate, they're going to get low signal strength, they're going to receive low performance. And then beyond that, when you get down to sort of minus 85 dBm, it's around 4 dB signal to noise, you're going to get to a point where you can't connect to the ape anymore. You'd lose connection. So I like to talk about these areas in some terminology which people might be used to, but I've slightly changed it. So you may have heard of the want, don't care areas. Well, I've added in want, need, don't care. So there's we want good performance. We want people connecting in the green area. But we have to recognize that when they pass that primary signals threshold, they'll still be connected. And we need to have this yellow area. And if we don't have it, actually we'll get per roaming experience. So this is an area we need it, and we need it for roaming, capacity, redundancy. That's what we need in modern day networks. So we want best performance, but we also need to have these other things. And then we come to the area where we don't want our clients connected. We don't want our clients to experience per performance. We don't really, they should have always roamed by that orange area. They shouldn't be connected in it. And then obviously we've got what we don't want, where we lose connection. If we look at that now inside, now let me maybe flip to a slightly different project here. We will go to This one, I think. So I'm just going to, now I've got a design here, which is a pretty good design, but what I'm going to do is I'm just going to slightly modify it. And we're going to look at a problem that we may have. So I am going to delete some APs. And we're just going to look at a design in this area here of the building. So I'm going to look at primary coverage. And what we'll do is we'll stick an AP down over here. Now this AP, if we look at it, we've put it nicely in its corridor. And what it's doing is it's covering quite a good number of rooms. So in terms of painting it green, the map, it looks pretty good. And you'll probably consider that looks quite good. But look what happens as we walk down this corridor. I get to the bottom of the corridor and I have got minus 64 dBm. I've still got good quality signal. I'm nowhere near my roaming thresholds. My client won't even think about roaming because they've got that good green signal. But then in 2 steps, I'm into my red. I walk around this corner and I lose my signal. This yellow area is practically non-existent. So I don't have that area I need. And this is where we're going to actually get a lousy roaming experience. So we won't even try to roam, and then I do 1, 2 saps and oh, I've got no coverage. Now I've got to, when I've disconnected, I've now got to go up, scan the other channels. I haven't got that yellow area to do all of that where I can stay connected and roam. So this is where once we start putting APs into the room, we can see we get a much bigger area in the corridor where now the client's got much more chance as it's walking here to go, let me find other channels. And Wi-Fi frames go very fast. We're talking microseconds, but it's enough time before I'm going to lose connection. So as we start to think about designing some APs in this area, we're trying to, what I always like to do is click on each individual AP and go, do I have enough orange yellow area? And I'm going to sit there and try and place the APs and just click on each AP, checking I've got that nice area. And so I think as well as looking at the full heat map where you just see green secondary coverage, what I would encourage people to do is click on the APs individually and have a look at the coverage from each AP. I think that can be a really valuable approach to.
Hey, Peter, real quick, there was a question in chat around as you're moving APs and adding APs, that blue bar that goes across the top. You want me to explain that, or do you want to?
Yeah, no, please do explain it.
Yeah, so you'll notice that real thin blue line across the top there. It goes pretty quickly usually. So what it's actually doing is the way Hamina works, as Peter's moving APs around, it has a real-time heat map engine, right? So that heat map is being generated in real time, and it's at a fairly low resolution while you're moving APs around. But as soon as Peter stops moving APs, it takes multiple passes and increases the resolution. So you'll see that heat map get finer and finer detailed when Peter stops moving things around. And that's how the whole live kind of heat map engine works within Hamina.
Yeah, absolutely. So that's what that blue line's doing. But while it's moving, it doesn't stop me doing anything, which is what I like. I don't get a little spinny wheel saying I can't do anything. I can still move APs around, add APs. While that's processing, I can still do things. The software is fully functional. So that's really useful, I find, as well. So this is So that's something I think that's really important to consider when doing roaming, is thinking about the the yellow area. And then also when we're assessing our secondary coverage, we need to assess, do we, is it just roaming? Am I happy with these red areas? Or do I want full redundancy, as I've designed this other side over here more for, in which case I'm going to need to start adding a few additional APs into here if I want to have full, you know, for redundancy, AP redundancy. And this actually is a hospital map, so it might be that actually in a map like this, I'm actually going to want to make sure I do have enough APs to give myself that full redundancy. What I also want to talk about, though, is capacity. Because I think we've talked about roaming, we've talked about redundancy, they're both things that are needed in modern day networks, but even more so is capacity. We used to just do coverage designs. I think capacity has become really important. I think it's really, really hard to get right. I don't know if I've actually, let's just quickly come back here. I don't know if this is familiar with anyone. This is a cartoon from a MIS site, which I actually helped design. So I've run it in here, but I don't know if this is familiar with anyone. If you've ever done any capacity calculations in the past, you go, well, we've got 9,000 seats, we've got 4 devices per person, we need to support video streams, so we times the seats by the devices, and then we times it by how much bandwidth each person needs, and we get this massive number. And then we go, right, and how much can each AP do? And we end up needing so many access points that we're going to make a salesman really, really happy. I don't know if that's familiar with you, or even if maybe you don't do stadiums, maybe something like this is familiar in an auditorium. And this guy's here is, put in an access point every 20 centimeters in a grid above the auditorium. This is a joke, but the inspiration from this cartoon actually came from a real life project I was doing, where I had a customer of an 800-seater auditorium, and they had said, well, every user has 3 devices, and so therefore it went from 800 to well, I think they said 2 devices, but it's all went to 1,600 devices. And then they said, right, and they're all going to need to be able to do this. And therefore they went, okay, so you've got 1,600 devices all doing this amount of throughput at once. Then they calculated the max capacity of their APs, and then they worked out they needed, and I think in its 800-seater lecture theatre, they worked out they needed 38 access points. So they put them in with high gain, high density antennas pointing down in a grid over its seating bank. And it wasn't fair off this picture. And it was just way too many. So I don't know if that's familiar, but I often think when people often come up with capacity, they end up putting in too many APs, which is why I think it's important to chat about this. And there's lots of considerations. When we gather requirements, we do gather the maximum number of users, the devices, radio limits, applications, and we often come up with some sort of formula, I think, like this. So per user throughput is the average throughput required by each user, estimated from the user applications. Then we said the total required throughput is number of users times throughput on number of devices. And then we do maximum radio throughput is the data rate of the maximum MCS of the client or AP, whichever is lower. And then if you do data rate, throughput's about half, so we can times that by 2. And then you get the total number of radios is the total throughput required divided by the maximum radio throughput. But anyway, I would say please don't do that. After showing that, I'm going to say don't do it, okay? Because you end up with this massive number. And I think the thing that people do wrong, just to go back slightly to my last slide, is they don't think about user behavior. So the category of user, if it's an audience member or an auditorium member, what they're doing, they're mainly listening to a speaker. They're not using all their 3 devices at the same time. what are the chances that all 800 people are going to transmit at the same time? Someone doesn't stand at the front and go, okay, everybody get ready to hit go on your data transfer. 3, 2, 1, go. It just never happens. So what we need to do is we need to think, well, actually, we need to do some tests, and we need to use our experience of saying, well, actually, I've seen in this office environment, you can have 30 people connected to an AP and it works okay. Or you can have 50 people in a conference center, or a lecture theatre, we could have 60 people per AP. In a stadium, if there's 100 people associated, that's okay, because most of the time the phones are in their pocket, they're watching the sport. Every now and again, you get 2 or 3 people. So what it comes more down to taking all the information from your requirements, and ultimately, I think we need to come up with, and I'm not going to go through all these slides, but there's a link to a talk I did on why it's impossible to calculate Wi-Fi capacity. You can go and watch that if you want to hear my thoughts a bit more. But ultimately, I think, I've not put that slide in, ultimately, it comes down to one thing. We take all this information and we work out how many devices per AP can we support. And I actually think that's, when we come to designing capacity, that's ultimately the figure we need to come up with. But forget, all these other things. We want to say that per AP, we can support, so many voice calls, so many datas, but there's so many devices we're going to be happy with associating to our AP. And then that's when we can then put that information into Hamina. And actually, that's what Hamina shows. And I actually love the way Hamina does capacity. I think it's possibly, it just makes it so much easier to deal with things. So I want to quickly show that, if that's okay. And we'll use its hospital plan again. And I'm going to show you 2 ways of doing it. And I think there's pros and cons for both ways. I don't think there's one's the right way, one's the wrong way. But I've actually, inside its plan, I've actually drawn in, and I'm just hiding it at the moment because I've drawn a capacity area. Okay, and I'll try and show you. And this is a capacity area, and I've just drawn it around the outside of the building, the entire building. And I've put a number of devices. So I've estimated there's about 400 people working in this hospital. So there's 400 laptops, MacBooks, if you want to put it that way. There's maybe about half of them will have iPhones, half will have Android phones, so about 200 each phones, and there might be 100 tablets. Half the users have tablets. So I've thrown in some devices into the capacity calculations. And I've said this is a number of devices we need to support. Now, what Hamina does is it takes those devices, and this is why it's important to understand, and it just spreads them out over the area I've drawn, sort of equally. So imagine all those devices spread out in like a grid over the area. And then once I turn on capacity, you'll notice there's another little icon underneath each radio. So we've got the 2.4 gig radio, the 5 gig, and the 6 gig radio. And some of these are red. And red indicates that I'm failing capacity. So what does that mean, and how does it do that? Well, I can see here that, yes, 5 at the bottom here. I'll just move the zoom window out of the way so I can see it. At the 5 of my 5 gig radios are failing capacity, and I can come down here and I can see how many clients are connected. I can also see what limits am I working to. So at the moment, I've got this configured that we can have up to 30 devices connecting to 2.4 gig radios, 45 gig, and 50 on the 6 gig radio. And you can see I can modify those as well, should I want to put in a different number for these limits. But they're the limits we're working with for this design. I've also got how many clients are currently on 6 gig. And you can see I can modify that number. A 30%, I think, is about typical for modern day networks today. It is going to depend on your environment. Before the iPhone came out, we were seeing about 10%. But since the iPhone, it's probably at about 30 and creeping up at the moment. So let's take a look at where I'm failing capacity. And you'll find, and it's actually, I think it's interesting. If we look at this plan, I'm just going to turn up coverage so you can see the plan a bit better. And if we look in 3D, you can see there's a courtyard in the middle of this building. And there's some windows in there, so the signal is going to flood out into the courtyard. But where am I failing capacity? It's the APs around the courtyard. You notice that? And that's because all these devices have been put equally over its area. So there's loads of devices in the courtyard and no APs in the courtyard. Well, I don't really want devices in the courtyard. And that's why all my APs around the courtyard are failing capacity. So this is what I really like about it. I can sit there and do this. I'm going to create a new capacity zone, and I'm going to call it the courtyard. And I'm just going to zoom in here, and I'm just going to draw around my courtyard. So what I'm effectively doing, because I've said this, I'm saying there's now no devices in the courtyard. And what that will do is that will push all the other devices which have been put into the courtyard back into my building. So now they're equally spaced out around here. So where my APs around the edges didn't have as many APs, have now got more. And look, most of my APs are not failing capacity anymore, because I've made sure the devices are where the devices really are. All but one. There's one AP failing capacity now, and it's this one here in the dining area. And it's a much bigger area. And actually, one AP might cover it from a heat map point of view. If we just look at primary coverage again. But it's probably in a dining room that size, we would have lots of users. So actually, I think that's quite realistic that we might want to go, okay, let's stick a second AP in this area. And when I do that, I've now split my users, and I've now designed this building to meet capacity of the number of devices I have. So I think that's why I like this tool. It very quickly shows me where I need to add additional APs for capacity once I've done my primary and secondary coverage design. So that's one way of doing capacity when you've got the entire building. The other way you could do capacity is, let's say you had a building plan. I'm just going to say, I think I've actually got one here. Just going to learn it very quickly. In this building plan, again, I'm just going to delete a couple of APs, but we got these APs, this building plan, and you'll see on it, there's lots of numbers written. Someone ran around and wrote the capacity in every room. So there's 32 in this room, 17, 12, 24, 28, the number of users in each room. So we've got that information in here. And what I've done then is, if we look at the capacity zones drawn, I've said in this little one here where this lecture theatre is, there's 238. This one, there's going to be 9 devices. So I've drawn individual capacities based upon what we know for each area. So there's 17 MacBooks in that little square there in that room. From a heat map point of view, I'm pretty much covering all the rooms I needed to. But we can see that we probably could do a few extra APs down here at the bottom. But from a capacity, I'm failing. So it's lecture theatre, massively failing capacity. So
And
again,
I'm curious if you take a client view and put that in there, what does that look like from a client? Obviously, it's going to show kind of the same kind of thing of 348% capacity.
But the AP covers it, minus 53 dBm. So straight away, I can see that by doing this, in this lecture theatre, clearly we would need, you know, more APs inside here. And we can design it as such, where I just, you know, probably need about 6 access points probably in a lecture theatre up this size. And once I add those, I'm now not got any red icons at the bottom up here. I've got the red ones here on the 6 gig radios. I've got a problem with co-channel interference. That's probably just because of my channel settings here, though, because you can see that I've got 80 meg channels on 6 gig. Probably in high density environments, I want to change that back to 20.
You could also use the auto channel width feature that was recently added as well.
I could,
and
yeah.
see what Hamina suggests that you should use. Probably what you just selected, but
it probably would be what I just selected. But yeah, and again here, this is another lecture theatre, and again, I probably just need to add in a, you know, some other APs into it. So, but I really like the fact that I can just see that capacity really simply, really quickly, and I can see where I'm failing capacity and where I need to add additional APs into this design. So I think it makes it very quick and easy to deal with capacity. And I've never had in a design tool something that can show me as easily how many clients are associated to each AP and when. So they're just 2 different ways of doing capacity, either lots of small areas or a big area over the entire plan. And I guess it's going to depend, you know, what suits your needs the most.
So I've got a question. So on the
Yeah.
capacity side, we were specifying the different types of devices. You know, you had some
Mm.
iPhone, Android devices, MacBooks, you know, things like that. Why does that matter from a capacity standpoint? Is that important? You know, what impact does that have on our capacity planning?
Yeah, I think that's a good question. I would say it doesn't matter hugely. It is linked to the client view. So Hamina knows how a MacBook roams, where it's likely to be associated and things like that. So it's it in terms of calculating which devices will be associated to each AP, it matters. But you know, Hamina doesn't have all the devices in there. So I had this question the other day: what if I've got a Windows laptop? I just pick MacBook, you know, because all Windows laptops work differently, so they couldn't possibly have me one in there. In fact, I believe you can use a tool in 2 different ways. Sometimes you're doing capacity per device, and if I'm doing it per device, I'll probably say, you know, I might go, well, actually, I can allow 50 devices per AP or 60. It might be a high number because I'm doing it per device. But sometimes you want to do it per user. You don't care how many devices I have. A user's going to generally use 1 device at a time. I don't care if they're streaming music. Let's say a student study room in a university. I don't care if they're streaming music over the phone and looking at some lecture notes on the laptop, or if they're streaming music and using the laptop, 1 device for the same thing. They're using the same capacity. So sometimes you want to do it in user. And I would just say MacBook and put my number of users in. And then maybe if I'm doing it per user, I might have lower limits. I might only want 30 users per AP. But with Hamina, you can do the same. I don't worry too much about what device it says. Me personally, I don't worry whether it says MacBook. It says to me, it's just a device, a user, which I want to do. And I use them. Sometimes I want to do it per device. Sometimes I want to do it per user. And I don't really worry too much about what it says next to that. I don't know if that answers people's question.
Yeah, I think that's a great answer. Yeah. There are a few questions in here, and I see we're about 10 minutes to the top of the hour, so I want to try and keep this to you know, make sure we have some time for Q&A.
Yeah, let's do that.
Yeah, so there's a good question in here by Eduardo on how does full redundancy affect roaming? We didn't spend too much time talking about redundancy and yeah, some of the trade-offs of if you do design a network for, let's say, full redundancy of, let's say your primary is -67 and your secondary for full redundancy then would be -67 as well. How does that potentially impact things like roaming?
Yeah. providing you're obviously minimizing your co-channel contention, which you may run into a bit with you in full redundancy, it shouldn't affect your roaming too much. What you might find, what I found with full redundancy, when you do use the little roaming man, and I don't know if I can quickly show this, but I'll need to go back to sharing. You will find there might be APs that are never touched, that no one ever roams to, and they'll only come into play when you actually when you actually have a failure of an AP and you use that redundancy. So if we go to this hotel again, which we just designed, what happens if we put our client view on here?
I'm
I
curious
often find
if you look at this one and look at the secondary signal, and let's set the secondary signal requirements to be the same as the primary, and let's see how close they match.
Yeah, I was just interested is look at them. They're connected to this AP here.
Yep.
Okay. And there's two APs in the foyer, and I roam to one, but you see that other one in the foyer?
Yeah.
I can't get it to ever roam this AP here. I can't actually, whatever I do, I can come in this room. I can't actually ever get it. I needed it for secondary coverage, but can I? Oh, I have got it now to roam. I think I went out the walls of the building, but
Yeah.
but normally it just doesn't seem to roam to it. And I
Goes right
think
over
that's
it.
it goes and I think that's normal when you're doing you might find, and I don't know if you've seen this on your wireless controllers when you look at associations per AP. Have you ever found there's some APs that just never get any associations, or maybe one or two? And you look at where they are and you go, well, they're right where loads of users are. And the AP next to it has loads of associations. That's because of this exact issue. Is that, okay, yes, it's there, but it's just not in a position where, and you're never going to roam to it because of where other APs are. And that happens quite commonly, I think, in network. So hopefully you add in extra APs that it won't actually affect your roaming. But what you might find is no one actually connects to some of your APs until you have a failure.
And another point that we haven't talked about really at all is power levels, right? So right now we're just in Hamina, something to be aware of when you place these APs. They're all starting off at kind of like a half power is pretty much kind of the default, and usually the 2.4 is going to be slightly lower, 4 dB less than like your 5 gigahertz radio is kind of the defaults in Hamina. But yeah, if you're designing for something like full redundancy, you're probably not going to be running the APs at maybe that high of power level. And these are transmit power is another thing to be aware of. This is the actual like raw IR conductive power at the radio. This is not EIRP values here. These are the IR values that we're defining in dBm.
Yeah, I think that is helpful to know, actually, isn't it, if you're designing. And then what Hamina does is it takes the antenna and adds the antenna gain for predicting the coverage, but you're putting in the IR values. Yeah.
Yep. So yeah, I probably would want to tune that a little bit. I don't think that's going to have a huge impact on things overall. When you have that dense of APs, you're still going to have that situation like Peter's describing, where it's going to likely skip over one or maybe even two APs before it's actually going to roam to another AP when you have that dense number of APs. Okay, let's see here. Any other questions? I know there were some questions in chat. I apologize if I missed them. They might have scrolled past already. If you do have questions, put them into the Q&A. I've been answering those as we've been going along. But yes, any other questions? Any other things that we missed on the important roaming capacity redundancy topic? Anders had a good point around the roaming man maybe would roam differently if some of the APs had a lot of load in clients, right? That could also have an impact on the decision making from the client side if it sees that AP is advertising a lot of load on that AP.
It could do, yeah. It depends obviously on client to client. They all roam differently and have a different algorithm. Most modern day clients do it based upon a predicted throughput, which is very interesting. So you look at the iPhone and Android are doing this now. They're trying to predict what throughput they'll get to an AP. And when they're selecting a BSS, they select the one they think they'll get the most predicted throughput through. So I've not seen many, when you look at the details, actually taking into account, although it's there in the beacons, actually taking into account AP load in that calculation, because they tell you what they're taking into account. The biggest thing which seems to affect it is channel width. So if you've got a mixture of channel widths, clients will nearly always prefer the wider channel.
Yeah, this is good.
So that does make a big difference.
Yep. That's I think a really interesting one, because yeah, we've gotten into this kind of situation nowadays with 802.11 AC at least for introducing like 160 megahertz wide channels. So now we have the channel widths could be 20, 40, or 160 in an enterprise environment. Hopefully not very often 160, but theoretically, the equipment supports that. And what happens in the environments that, yeah, you have maybe certain areas of a building, maybe a certain floor where you're deploying newer APs and you want to use the 802.11 AC at its full capacity, full data rate. So you turn on 80 megahertz channels there, but then on the floor below, you're running older technology or denser APs and you're only using 20 or 40 megahertz wide channels. That could be a really bad situation, right? Because now your clients are saying, oh, there's 80 megahertz wide channels I can hear. They're on the floor above, and now it's favoring those APs and roaming to those APs rather than the AP that it's right near on the floor that it's on.
Yeah.
There was a question around RCR concept in an LPV, a large public venue environment. I think definitely, obviously, the capacity component of RCR is obviously a big one.
Yeah.
The other two, though, aren't as important, right, as far as roaming and redundancy in an LPV environment.
Well, you're going to know, I would say not as important, but capacity becomes, in a large environment, that's where the number of devices becomes really important. So I've said in some environments, you might just do number of users. In these large environments, the number of devices actually becomes really important, because you can actually get to a point where you actually hit the maximum number of associations per AP. And you've got to make sure you've got enough APs to actually associate all the devices. And that can start to become an issue. And you've also got to think about, let's take a stadium. What happens at halftime? Everyone stands up and goes onto the concourse, either to buy food or to go to the bathrooms. And suddenly you get a large number of users all roaming at once. So APs can suddenly get oversaturated. So we tend to always leave about half the capacity in an AP when at a planning stage, so that we can cope with large number of users suddenly move into around APs. So that becomes something to really important to consider, that per radio association limit when doing those large public venues.
Kit asked an important question. How do I keep my lab work area so clean? I'd say don't look what's on my desk. My desk is my desk is very messy. I just keep
really
the stuff behind
question.
me more organized, which isn't even that clean. But yes, I appreciate it. But yeah, don't look at my desk.
Yeah, and there was another question here about any CECs for Hamina training yet. No, not yet, although that has been asked before, so I was going to contact them. But there is CW&E, continuing education credits. That's been agreed with CW&P. So if you want your CW&P CEs, you will get those for a Hamina training class if you sit one. But we will have a look at adding some more as well in the future.
There was a question around clutter data to outdoor design. So obviously completely kind of off topic from this webinar, but that is definitely something that is under consideration. I'll actually share a link to the user suggestion page for that. But yeah, that is something that has been, I know, being discussed. Hasn't honestly received a ton of interest, at least like on the user suggestion page. but I'll throw a link to that in chat if that is something that you work with and would be very useful to you. There's a good useful user suggestion around that topic that you can upvote there.
Yeah, I think particularly for the cellular planning, I think that could become very useful.
Yep. There was one question going back to the topic that we were talking about before around roaming and redundancy, wanting some more clarification around that, around specifically how does redundancy affect the data rate? So that's an interesting one. I'm curious your thoughts on that. So if you were designing, Peter, for full redundancy, what does that look like from a data rate standpoint?
Yeah, how does it affect a data rate? That is an interesting one. Obviously, you know, data rate is ultimately going to be linked to, well, we like to think of it as being linked to signal strength or signal to noise ratio. In reality, it's not technically true. Your clients will always try and transmit at the highest data rate, and then if it fails, they will after a while reduce the data rate. And why do they fail? Well, it could be it's sort of loosely linked to signal to noise because it could be just a lack of signal. It could be an interference source, but it's something that's causing them not to get acknowledgements for their data. So obviously, the more APs you have, you could on one side said, well, I'm always going to get a good signal strength wherever I am, so I'm always going to get a good data rate. The potential downside is as you add more devices, you've got more chance of having co-channel interference, or as I like to call it, co-channel contention. So it's about trying to design in a way where we minimize that as well, because obviously that's your danger. And if you can start to hear 4 other APs all on the same channel, you're going to start to run into some problems there.
Let's actually see if I can demo this real quick, because I'm curious. So we talked about that automatic channel width. So let's say, okay, we're going to allow Hamina to use all the way up to 160 megahertz wide channels, which is going to drive our data rate, right? And I'm going to say we'll even let it use all the way up to 320 megahertz wide channels on 6 gigahertz.
Okay.
But I'm going to say Hamina gets the choice of choosing what's going to be the most optimal based on what Peter's talking about of the channel interference standpoint. So let's see what ends up happening if we do design this network for, let's say, 5 gigahertz, and we're going to say secondary, we're going to make the same as primary. So we're going to design for neg 65 on the secondary as well as the primary. And what ends up happening is our data rates are going to start to change, right? So I'm going to start placing some APs. Let's actually do a proper AP here. I'll do a 6 gigahertz capable. Let's do like a 635, nothing too crazy. I'm just going to delete the APs off of here, and let's just plan this out, see how quickly we can do this here. So as I start to place the AP, you're going to see that secondary coverage start to build out. And this is going to be for full redundancy now, right? So we're going to end up with a lot of APs.
Ooh,
and notice our channel width.
40, and now just gone to 20 already. Yeah.
Drop that quickly. So we're down to 20 on 5 gigahertz. We're still at 80 on 6 gigahertz though. So we're actually doing okay on 6 gigahertz. But when you end up with this many APs, that's obviously going to drop our data rates. What was that?
I said, come to Europe and you'll be on 20s on
yeah,
6
this is in the US.
well.
That's a good point. Yeah, this varies quite a bit based on your country as well of what spectrum. But I've got 1200 megahertz to work with, and look at that, we're already down to 40 megahertz wide channels now on 6 gigahertz, and I haven't even finished building this out for full redundancy yet. So I bet you by the time we get done with this, if I actually really got this thing dialed in for full redundancy, we're probably going to see, even with 1200 megahertz wide channels, maybe we could still pull off 40s. This is getting pretty close. Let's say that's good. Clean this up a little bit. I'm going to remove the channels and also the capacity, so we just see the APs. But this is what we end up with as far as the APs. Now let's see from a client view, what are we talking about for data rates, right? So data rates, you know, we're on 2.4 right now. And let's see if we can get this guy to roam over. There we go. Now we're on 5 gigahertz. So yeah, 258 megabits per second. Let's say if this is a 6 gigahertz capable phone, since we have some 6 gigahertz capable APs, Now I got it roamed over to 6 gigahertz. So we're getting 459 megabits per second. So yeah, you're definitely going to see some lower data rates. That's still really good, right? And with the US and 6 gigahertz, even for full redundancy, we can get some pretty good data rates. However, if we were, going to override the system here, and I'm going to turn this off, and I'm going to say we're going to use, I don't know, let's do something a little more realistic, and we'll say 80s there, and we'll say 40s here. Now we're going to introduce more channel interference, but now I'm going to get much higher data rates, right? Now I'm getting, if I'm right next to the AP, 1200 megabits per second. However, we're probably going to start running into some interference issues because of how many APs we have in this environment. So optimally, yeah. So there you go. There you go. You can see now the interference that we've now introduced in this environment by overriding it. So I've got higher data rates, but I've got co-channel contention that is going to obviously degrade that overall performance. So it's a trade-off, right? Do you want higher data rates, or do you want better user experience by reducing that co-channel interference? I think it's a really important topic.
I think it's an important topic and a question which often we don't talk about, because sometimes if my users are, I've got lots of users, I've got lots of APs, but my users are not doing too much. The Wi-Fi usage is light. I probably will go for the higher data rate and accept the co-channel contention, because the chances of those two, the user groups using the same channel transmitting at the same time is actually is not as high. But if I've got a very heavy usage wireless network, where there's an awful lot of data being transmitted all the time, and that's when I'm probably will want to have less co-channel interference and have smaller channels. So
definitely a balancing act.
It is definitely co-channel, and this is why I don't call it interference contention, isn't always bad. In some environments, you might go, actually, I'll accept some, because having the higher data rates will ultimately give me overall better performance. And it is a balancing act. You never want lots of it, but sometimes actually accepting a little bit is okay.
Yep, I fully agree with that. Yeah, you want to avoid it as much as possible, but at the same time, it's a give and take, right?
Yeah.
You're never going to get rid of 100% of co-channel interference, co-channel contention. Yeah, I think you got to balance the data rates versus how much you're willing to accept some of that contention on the medium.
Yeah.
Very good question. Well, I see we're definitely over on time. Any last questions we should try to answer here quickly before we wrap this up?
Just having a quick look. So someone's put, which values of RSSI do you consider for roaming off iPhone, Android, Windows, laptops, MacBooks? I think that's a difficult one, because every device roams at different thresholds. iPhone's typically mine at 72 dBm, and I tend to use that as a good sort of default roaming threshold for devices. A lot of devices roam around there or a bit before, so it's not a bad threshold to use.
And we've got those different profiles in Hamina. These are modeling those roaming behaviors for each of these devices. So this isn't just some kind of generic thing in there. There's actually a lot kind of behind the scenes there to make those decisions in the tool. And that's why the list is as short as it is. It's very hard to get that information. I know we've been having a lot of internal conversations of trying to build it out more. So if anybody on the call has connections to folks on the Windows side of things, the laptop side of things, we definitely would like to build that out. I know we've been looking at adding some devices from folks from like Zebra as well. Just trying to get to the right people that have that level of information is most of the challenge there. Excellent. All right. Well, we can wrap things up here. Really appreciate everybody sticking around and asking these questions. Hopefully we're able to answer most of those. If I did miss any questions in chat or anything like that, feel free to reach out to myself directly, jerry@hamina.com. I'll throw my email in chat there. Happy to do a follow-up call or anything like that if we weren't clear on any of this kind of stuff. But yeah, I'm sure, Peter, what about you? How can people reach you on LinkedIn or Twitter, or what's your preference?
Yeah, they can reach me on. I'm always available there on Twitter at Mackenzie Wi-Fi, or they can email me at peter@mqtx.co.uk. I will as well if they want to email me.
Excellent. Well, thank you so much, Peter, for being on and helping me cover this important but challenging topic. And yeah, thanks everybody else for attending. Appreciate it.
It's been an absolute pleasure. Thank you for having me, Joey.
Yeah, have a great rest of the day, everybody.